Hi, I'm Liber Chakos and I'm standing in front of Tasmania's first certified Green Smart house. The house has been built in the new housing subdivision called Kingston Green. We're about 10 minutes drive from the city of Hobart, and the house has been built to look much the same as the other houses in this new housing subdivision, with some subtle differences. And what I'm going to do today is share those subtle differences with you and show you how you can put them to work in your home to make it much more energy efficient, more comfortable, and a much more enjoyable place to live for you and your family. So come on inside and let's have a look. So here we are inside Tasmania's first certified Green Smart home. Now, Green Smart is an initiative that's run and organised by the Housing Industry Association all the way across Australia. It's a voluntary organisation where your builder can focus their expertise on energy efficiency, on water saving principles, and also on healthy homes principles. And the first step in having a Green Smart home or an energy efficient home is to have an energy audit done. And in this home I've used the first-rate software. And that software is great because it allows us to break down the home into a number of elements so that we can focus on those and make sure from each of those elements we're getting the best value and the best efficiency to get an overall big picture for your home. Now, the elements include your windows, it includes insulation, it shows you how to manage thermal mass for the most efficiency, and it also includes cross-flow ventilation and the design of your home. So come down into the kitchen now and I'll show you how this home has incorporated north-facing design to make it much more energy efficient. The single most cost-effective way to make your home more energy efficient is to get the design right. Make your home a passive solar house. What I mean by that is to face the home north. You want the living areas and the larger window areas on the north side of your house to take advantage of the sun. And the sun works differently throughout the year. During winter it's much lower in the sky, and during summer it's much higher up in the sky. And so we can use eaves to take advantage of that. Eaves are the roof overhang on the outside of your house. And depending on where you are in Australia, you want to get the eaves width right, because the wider the eaves, the more protection you're going to get from the summer sun. Also, the wider the eaves, the more winter sun you're going to keep out of your house as well. So down here in Hobart, we've got wider eaves out here in the living area to keep that summer sun out. It's wide enough though that in winter the sun comes all the way back to the south side of the house and really warms up the house. So the eave width we've got here works beautifully. Now, on the northeast corner of the house we've got a bedroom there, and there are no eaves over that bedroom. That's been done to incorporate the style of the house that the architect came up with. What we do have though is a pergola out the front there, and that pergola gives the option to provide a retractable eave, because even in winter that bedroom can get really warm. So the retractable eave provides an option for you to make the temperature much more comfortable in your temperature range. It's a really good alternative to make your home suit the temperature and the comfort levels that you like. So now we know how to design the house and use the windows. Let's go over and I'll show you the type of energy efficient windows that I've put into the display home. The windows that I've selected for this home are aluminium double-glazed windows, and I've used them throughout the house except at the front and back doors. Now, with double-glazed windows there are three components that you need to look at and make decisions about. The first of those are the type of frame. The second decision is the type of glass that you put in the window, and the third is the air gap, the gap between the two panes of glass. Now, the type of glass that I've selected for the display home is plain glass. It's clear glass. There are alternatives available now, tinted glass or Comfort Tone Plus, those sorts of glass that will stop the UV from coming into your home. We don't need it in this house because we've got nice wide eaves, as I've mentioned earlier, to protect the house from the summer sun. The second component is the air gap, and that's a really crucial part in a double glazed window. You want a minimum of 12 millimetres for your air gap. And the reason you need that minimum 12 millimetres is to stop the heat transfer from one pane of glass to the other pane of glass. You need that air gap to provide the insulation. People in the past have said to me that they thought that it was the thickness of the glass in the window that provides thermal insulation, and it's not the case. It's the air gap that does that. If you can get an air gap up to 16 millimetres, 18 millimetres or so, then that's even better. If they get too big, the problem is that it will encourage the heat flow or airflow inside your window, which will encourage that heat transfer. And again, I'll repeat it, what you want to do with that air gap is stop the heat transfer from one pane of glass to the other pane of glass. Now the third component is the type of frame, and it really is crucial to making sure you've got an energy efficient window. There are three options. You can use aluminium that we've used in the display home. The other options available are timber. Timber is perhaps the most energy efficient type of window frame that you can have because it's an insulator. It works really well and it's really energy efficient. If you're not comfortable with using timber because you don't like the maintenance or the upkeep, then you can go to a PVC frame. PVC is an insulator as well, so it's a really energy efficient window frame. Now, if you're not comfortable with PVC or timber, then I've got really good news for you. You can stick with aluminium because now there's a new product available, and that's called a thermally broken aluminium double glazed window. And the way that it works is when they are manufactured, there is a division between the inside and the outside of the frame, an insulating division that stops that heat transfer across the two from the inside to the outside. And again, it makes it a really cost-effective way to have a highly insulated double glazed window. So now we've got the insulation in our windows right, let's have a look at what we've done inside the walls on the outside of the house to keep the house insulated really well. And what I'm going to do is take you across to a house that's being built at the moment in this estate and show you what they're doing in their house, which is the standard type of insulation that most homes have, and I'll explain to you why we've selected the type of insulation for the display home. So come on over and let's have a look at that. Before we go over and have a look at the walls, I'd really like to tell you what we've done in the ceiling for insulation, and remembering that it is so important to make sure that there's no gaps in your insulation for the heat to go through. And what we've done in this house is used cool and cozy insulation. Cool and cozy is a blow-in insulation. So you blow it into this ceiling space, it sits on top of your plasterboard, nice and deep, and we've got an R3.5 value here in this house. And the most important thing is that it fits all those difficult areas that's hard to get to with the normal bats. So all the nooks and crannies are really filled up with the blow-in insulation, making it really effective, and that's so important. So come on over and I'll show you what we've done in the walls as well. We've walked across the road to another house that's being built right now in the same estate, and we're going to cover insulation here. Insulation's really a key component to an energy efficient house, and there's a couple of things that we're going to cover. One, the type of insulation to use, and two, the installation of the insulation. Now here we've got the standard format for insulation in most new homes, and we've got the sarking paper on the outside of the house, and inside we've got the famous pink bats. Now here we've got a good view of how the pink bats get installed, and they're in nice and tight. The problem with putting the pink bats in nice and tight is that they lean up and touch against the sarking, the silver paper on the outside of the stud. And here it is there, the reflective foil insulation that gets wrapped around the building. Now the problem is when the bulk bat or any type of insulation touches that reflective foil, it cuts down your insulation by as much as half. So if you're putting an R1.5 bat in your wall with the reflective foil, in theory you'll get around about R1.9 or maybe even a little bit higher. But if it gets installed incorrectly, and when the installer puts it in, generally they'll push it in as much as they can, and even when they're being careful, because the bat itself really fits snugly into the depth of the timber stud wall, it more than likely won't leave that 25mm air gap which you need between this and the reflective foil behind. That's really crucial. The other area of gaps that we're going to have a look at are if you have gaps in your insulation themselves. Here the installer's done a pretty good job and there's very minimal gaps. But if you've got around about a 5% level of gaps in your insulation, again, that will lead itself to giving you up to 10% reduction in the effectiveness of your insulation. If your gaps are as high as 10%, then that means the effectiveness of your insulation can drop by as much as 50%. So making sure that you can't see through your insulation at all is really crucial to getting the most out of your insulation. Now I'll show you what I've done in the display home. Instead of putting these in, which are really tricky to install, I've put in a product called concertina foil bats. And there's a couple of reasons I've done that. One is health concerns. There's a lot of allergies and asthma around nowadays, and a product like fiberglass can really irritate those sorts of allergies. So I haven't got any fiberglass at all in the insulation products in that home. Instead I've used concertina foil bats. And these fit in between the studs like so. They get stapled to either side, and I've put 2 layers in which provide 3 air pockets with the sarking paper on the outside. And as far as insulation, what just about every product we use for insulation, what it does, it's providing air pockets. In this product here, it's not the fiberglass itself that's doing the insulating, but it's the little air pockets that are incorporated in that fiberglass bat. With the concertina foil bat, we've got two air pockets in there. As well as that, we've got the reflective foil insulation. Insulation doesn't really insulate against cold in winter. What it does, it keeps the heat inside the house. Insulation always works with heat. You need to remember that cold basically is a lack of heat. In summertime, the way reflective foil works is by reflecting 93% of the radiant heat that comes out of the sun. In wintertime, it reflects the heat back into your home, and incorporated with air pockets provides a level of insulation in that house over there, the display home, of more than R3 in the walls. And that's a really effective way to insulate your home. And if your insulation with bats are put in incorrectly, then chances are you've only got around about R1, maybe R1.5 in your walls. So we've got more than double that type of insulation. Now that you've got your insulation right, we're going to talk about thermal mass and how we can maximise that in a comfortable home. So here we are, we're back inside the house. We've got our insulation right and it's installed correctly. And now I'm going to talk about a design element of the house called thermal mass. Thermal mass is one of those technical terms that needs just a little bit of explanation. Basically, all thermal mass is the introduction of any heavy object into your home that will store heat energy. What we've done in the display home is we've incorporated a concrete slab throughout the house. And right here on the northern face of the house, we've introduced these dark ceramic tiles to really help absorb that beautiful warm northern sunshine. And the way thermal mass operates is that this heavy item, like concrete that we've used here, will absorb during the warmer periods of the day all of that heat energy. And then when the sun goes away and the temperature starts to cool down, the concrete will re-radiate that energy heat and maintain a consistent temperature inside the house. And that's the whole purpose of thermal mass. Instead of having these large fluctuations where we go from hot to cold to hot to cold, thermal mass helps narrow down that band of temperature fluctuations, providing a much more consistent and comfortable temperature inside your home. Another element that we can use to do that is cross-flow ventilation. And all cross-flow ventilation is using the house design to take cooler air from the back of the house, in this instance, from the south side of the house, and pushing out the warmer air that gets collected during the course of the day. You can see all the beautiful sunshine on the north side of the house here. We don't get that on the south side of the house, and the temperature out there can be as much as 10 degrees lower than it is out the front. And so by opening the windows and the doors on the south side of the house, that encourages that cool air to come through and make a big difference in dropping the temperature inside the home. So they're the major design elements that we've spoken about. Now we're going to go out onto the deck, and I'm going to show you one way where you can cut a massive amount of the greenhouse gases that your home emits and save you a whole bundle on your electricity bill. So come on out onto the deck. In the average Australian house, as much as 30% of our electricity needs, our electricity costs, are required to produce hot water for the house. So that provides us with a really good opportunity to save our electricity bill, to save greenhouse gas emissions, and do it really cost effectively. What we've done to address that in Tasmania's first certified Green Smart house is to put a flat plate solar hot water system up on the roof. Now, one thing that we don't take advantage of in Australia enough is the amount of sunlight that we get. And in Melbourne, for example, you get as much sun as they do in the south of Spain and in North Africa. So let's take advantage of it. A couple of things about hot water. First thing you want to do is make sure that you locate it as efficiently as possible. In our home here, we've located it right in the centre of the roof, in the centre of the house. And that divides it evenly between the hot water needs in the bathroom and the hot water needs on the other side of the house in the ensuite. So that provides a level of efficiency right there. Now, a couple of alternatives to flat plate solar hot water technology, which has been in Australia for around about 50 years now. A couple of alternatives include heat pump hot water and evacuated tube solar hot water. Evacuated tube technology is fantastic, and it can provide as much as 40% increase in energy efficiency above flat plate hot water. And what that means, and the reason that we get that, is through the evacuated tubes. It's basically made up of an array of evacuated tubes, and these tubes, being cylindrical, provide you with greater surface area to attract and collect more sunlight. And some of the systems have got mirrors underneath, so it reflects the sunlight again, increasing that energy efficiency. And depending on the needs and the usage in your house, you can add arrays to increase the level of hot water that gets produced. The other alternative that I spoke about is heat pump hot water system, and that system works basically in the same way as a reverse cycle air conditioner or as a refrigeration unit, and it collects cool air and converts that cool air into warm air and energy, creating the hot water. And they can save as much as 75% of your hot water costs and energy, rain, hail or shine. They don't need the sunshine to do that. So if you live in an area where you're overshadowed by other buildings or by trees or a nearby hill or mountain, then perhaps a heat pump hot water unit will work really well for you. So now we've talked about hot water. Let's go over and have a look at how we can collect that water much more efficiently and save that very precious resource. Australia is the driest inhabited continent on Earth. And right here in Hobart, we live in the second driest capital city in Australia. So it's imperative that we save as much of that precious resource called water as we can. One way to do that at home is by planting Australian natives in your garden and by having a water-saving landscape design. In urban Australia, up to 25% of the water that we use at home is for landscaping purposes. So that's a very clear area that we can save a lot of water. Another way that we can do that is by incorporating a rainwater tank in our backyard. Here on this small urban block of 400 square metres, we've easily and comfortably fit a 5,000 litre rainwater tank. And this tank, the way that the house is designed and plumbed, will supply around about half of the needs of a small family that live in this house. There's enough room in this service courtyard to install another 5,000 litre rainwater tank, and that will supply almost all of the rainwater needs for this household. Now, the way to work out what size tank you need in your home is by doing this. You need to know how big your roof area is, how many square metres, and you need to know what the monthly average rainfalls are. And you take that monthly average rainfall, for this house it's around about 60 millimetres a month, and you times that by the roof area, which in this instance is around about 150 square metres. And that will give you a total of the litres that you will collect each month from the rain. Now we're going to go inside and I'm going to show you how this house helps people with asthma and also with allergies. I've worked in the building industry for over 20 years, and during that period something's come to my attention, and that is that we use a lot of materials in the industry that are highly toxic. I've spoken to a number of naturopaths and health professionals, and they've told me that the recent dramatic increase in the number of people that have asthma and allergies is partly due to the fact that we spend so much time indoors, whether that be at work or at home. And that, combined with the fact that we use these materials that are highly toxic, really does eat away at our immune system. And over time, we find that many of us have ended up with asthma or allergies that we don't know why we have. Now, the way that I've addressed that in the display home is by taking 5 steps. And those 5 steps include using a low toxin paint. And what I've selected is Wattle ID. Wattle ID is a commercially available paint. You can get it at most hardware stores and at most paint stores. And it's a really high quality paint, so you get a really good finish. And as well as that, the smell that you normally get from paints when you're painting houses or wherever is normally quite high. But when this house was painted, it didn't have that strong smell. The second thing that I've done is have a look at how the floors are covered. I've used hard surfaces in the living areas, including tiles and timber. And on the timber, again, I've gone for a water-based finish that has low toxins in it. And what that does is make sure, using the hard surfaces, make sure we eliminate as many of those dust mites as we can, because dust mites really can trigger asthma and allergies. In the bedrooms where we've used carpet, I've gone for a low pile carpet. That helps to minimise the amount of dust mites in the house. The other thing that we've done is use low toxic joinery. The joinery that I've used in the kitchen here and in the bathroom and ensuite, it's all made up of either E0 or E1 board. What that means is it has a rating where the amount of emissions, the amount of toxins that come out of the board is very minimal, either E0 or level E1. It's a European standard that makes sure that the quality of the air in the homes is kept to a high standard. The other thing that I've done is introduce a type of heating that's disappeared for quite a while in Australian homes, and that's off-peak heating. The heat banks that I have work on the off-peak tariff, so it's very energy efficient. And when it spreads the heat throughout the house, it does it in a gentle way. So it doesn't blow the heat around the place. It doesn't blow the air around the place, spreading and adding to the concerns of dust mites. In the 2 bathrooms, I've got under tile heating. Again, that's really comfortable, and it's not the hot heat coming from some heat lamps that we use nowadays. What that does as well is allow us to have really effective exhaust fans in the ensuite and the bathroom to make sure that we get all of that moisture out. And that's really important because when you have a high level of moisture, that encourages molds and fungal growth. And again, they can trigger asthma and allergies. So you want to maintain a clean bathroom and keep that mold out of there by reducing the amount of moisture in those areas. Now, the final thing that we've done is introduce plants into the display home, and you can do that at home really easily. What plants do, and especially broadleaf plants, is they actually absorb the VOCs, the volatile organic compounds, and they're the compounds that are the toxins in the materials. And these plants absorb those volatile organic compounds, and even the microbes at the top of the soil, is my understanding, they absorb the volatile organic compounds and provide a much better, much cleaner quality of air for you to live in. Now, as far as an extra design element that I've done here, there's a couple of things that make the house feel really good. And that's one comment that I've had over and over and over again from people when they come into the display home. They say there's something about the house that makes it feel really good, makes it feel inviting. And what I put that down to are 2 things. Firstly, I engaged a feng shui consultant. After the plans were drawn up, I asked the consultant to come in. And together we had a look at the plans, and she made some changes to the plans, and those changes really make the house work much, much better. She had a look at how the rooms work with each other and how they relate to each other. And she made a couple of modifications to make sure that those rooms worked really, really well together and they had a nice space around them. The other thing that she looked at was the colours that we used in the house. She introduced neutral, calming colours, and that keeps the house much more comfortable, feeling nice and relaxed. And on top of that, she introduced splashes of warm colours, different colours to lift our energy levels and make us feel good in the appropriate areas, in appropriate amounts, and in appropriate rooms. And that has made the room feel so much better, and the whole house feels so much better. The other thing that I've done is in this house, and this is similar to many of the other houses in this estate, they've got 9-foot ceilings in the living area. And what that means is it's a higher than standard living area. Normally we have 8-foot ceilings, 8 feet high, 2.4. So I've added an extra 300 millimetres, an extra foot, and that really does create a much bigger space in the area. Now, the energy efficiency purist may say that that's not a good thing to do because in theory it creates a bigger volume of space, a bigger area that you need to heat. I'm happy to make that sacrifice because it really does add to making the house feel much, much more comfortable. And that's what it's all about. It's about turning a house into a home, using energy efficiency, using design principles to create a much, much better effect and a much more comfortable place for you and your family to live. So there you have it, your personal tour of Tasmania's first certified Green Smart house. Recently, the house also received the award for excellence in energy efficient housing from the Master Builders Association here in Tasmania. And the feedback that I had from the Master Builders Association was that it was the first normal looking house to receive that award. And what that means is that you can take these principles and apply them to your home regardless of the style of your house, and you can make it a much more energy efficient, a much more comfortable and a much more livable place for you and your family. Now, if you want more information, then go to our website, and remember what we say here at Sunrise Homes: make your home a home for living.